We have studied right now about the capacitor circuits when they are in series and parallel. But in most of the cases, we will find these circuits in which both the combinations are equally used. So we'll talk of those type of combinations and how to find the potential, charge and the capacitance in such systems. Let's see a circuit. This is a mixed combination, some series and parallel. Let's see. There's a 6 millifarad capacitor, 8 and 4 millifarad and 36 volt battery. Now if we see the 6 millifarad is not in series with either 8 or 4 because the charge on 6 will be different than the charge on either 8 or 4, but the charge combined on 8 and 4 will be equal to 6. So hence, but we also see that 8 and 4 are themselves are in purely parallel. So first of all, we'll try to solve the circuit which is purely series or purely parallel. In this case, we'll talk of first of all 8 and 4. So we make a simplification. 8 plus 4 becomes 12. So now my circuit breaks into two parts. Series capacitors 6 and 12 now, because 12 has been replaced by 8 and 4. Now 12 and 6 are in series. So we should get the equivalent of 12 and 6, which will be 1 by 12 plus 1 by 6 equal to 1 by C, and hence we solve it. It comes out to be 4 millifarad. Now the question is, this is the net capacitance of this circuit. When you know net capacitance, you know net voltage, you can find net charge. So we can find the net charge on this system. The net charge on the system will be 144 millicoulomb. But how will this charge be redistributed? We will have to go back. We have to retrace the circuit in the same fashion. Now this 4 MF was made up, this 4 was made up by this 12 and 6. So we break them into 12 and 6. Now 12 and 6 were in series, and we know in series the charge remains same. So in our next circuit, when we break the circuit, we will see that 6 and 12 both are having 144 millicoulomb charge, as was this one. So both the charges remain same. Now this 12 was because of 8 and 4 in parallel. So in the next case, we will break this 12 into 8 and 4. Now the question is, this 8 and 4, prior to solving, we make the voltage across these. 6 MF having 144 millicoulomb will have the 24 volt by using Q is equal to CV. In this case, Q is this 144 is divided by this quantity 6 will be voltage. So this is 24, this is 12. In this case now, we have taken the 6 and 12 and find the respective voltage. Now this 12 can be made up from 4 and 8. In the next case, we'll make the 12 as 4 and 8 combination. But since this 4 and 8 were already in parallel, that means voltage across these both will remain as 12 volt only, same parallel. Now you can see from this diagram, I know now each and every capacitor having the voltage. So voltage of the capacitor is known, the capacitance is known. Now Q can be calculated knowing C and V. So I'll individually calculate the C and V, and this is what we get. Remember, in this case again, you can see 96 millicoulomb is charge on this 12, on this 8 MF, 48 on this 4. Joining 96 plus 48 will give you 144, and which is the same in this. What I mean to say is, when 12 and 4 were taken in parallel as a single 8 and 4 and combined added with this 6. So 6 and 12 were in series. They should have the same charge, which is already coming 144 in this, 48 in this, 96 in this. So now in this case, we have already found out the net capacitance, net charge on each end, every capacitor with the voltage. Now with this diagram, now you can find whatever you want. You want the energy in any capacitor, because Q, V, C all are known. Now you can play to find energy or voltage, whatever you want, you can find it out. So this is the way we have to usually solve the question with taking the basic things, in which case the individual things are taken which are purely in series or in purely parallel. We'll take some more circuits in due course of study, and please see them also so that you can have the more wider view of all these type of capacitor circuits. Thank you.